We're going to start talking about our next part of the geometry unit, which is circles. And let's make sure we understand what a circle is. Okay, we need to turn to page 1 in our packet. Okay, and this is the definition of a circle. A circle is all of the points that are in the same plane that lie at an equal distance from a center point. Okay, the circle is only composed of the points that would be on the border. You could think of a circle as a hula hoop. Okay, it's only the points on the border that are the circle. So for instance, if let's say I had a string and I tacked it to the desk and the string was this long. And I pulled that string and I had a pencil attached to it and I stretched it out as far as I could. And I traced around that center point until I came all the way back around. And that is what the definition of a circle is. A circle is all of these points that lie on this border, okay? And there's an infinite number of them. And they get so close together that they basically make something that looks like a line, and that's a circle, okay? Now, there's special parts of a circle, okay? So let's talk about those. When we talk about a word called circumference, we are talking about the distance around the circle. Okay, so if I could, let's say I have my little circle right here. Let's say if I could start on this point right here, and I can measure, and I can walk all the way around, and I measure how many, let's say, feet I've walked, that would be circumference. That would be similar to the perimeter of a shape. Okay, then we have what's called diameter. Okay, diameter is a straight line, D-I-A-M-E-T-E-R. Diameter is a straight line that passes through the center of the circle with the endpoints on the border. So for example, if this was the center of this circle right here, this dot, the distance across, I'm going to make it really big to emphasize, it's like a belly button. It will be the distance across through the center. So from side to side, so I'm on one border, I go through the center and I go all the way over to the other border. That's what's called diameter. And this is the distance across the circle through the center. Okay? That's diameter. And then we have, finally, we have what is called radius. Radius is the distance from the center of the circle to the outside border. So for instance, I'm gonna draw it over here. If I have a circle like this, and I have the center, and I'm gonna overemphasize it, I have the center, the radius is just the distance from the center to the outside edge, okay? And it's half of the diameter, because remember, the diameter is the distance what? All the way across, right? So if I go all the way across, I basically have two radius added together, okay? So the radius is just half of the diameter. It's half of the distance across the circle. Now, when we talk about formulas, we've used formulas before, but this unit's going to be very heavy with formulas. When we talk about formulas, we have to identify what some of the variables mean. Okay, so let's talk about what the variable for circumference. We use capital C when we talk about circumference. We use lowercase d when we talk about diameter, and we use lowercase r when we talk about radius. Okay, so let's use our definitions. Circumference is the distance around the circle. So it would be around the circle, okay? Diameter would be across the middle through the, across the circle, but it has to go through the center of the circle. And the radius would just be halfway across. Now there can be lots of radius, or radii, I guess is what you call it. We could have lots of radius, like the spoke of a bicycle. Excuse me? It doesn't matter. Circle's a circle, okay? It has no start, it has no end, okay? So let's use the definitions above to diagram and label the parts of each of these circles. For circumference, excuse me. Now you ask, where would I start? Well, we can actually start anywhere we want. So I'm going to say if I start here, circumference, if I'm going to measure it, if I could straighten this line out, it would be the distance all the way around this circle. So that would be circumference. We measure all the way around. So we basically measure this border all the way around. Diameter, again, I'm going to emphasize this is the center, okay? Diameter is going to be the distance, oh my goodness, sorry. The distance all the way across the shape, the circle through the center, okay? It has to be through the center. I can have several diameters as long as it starts on one side and it goes through the center and it touches the other side, that's a diameter too. It doesn't matter where that diameter is, it's still the same distance because all of these points are equal distance from the center. Eva, I need you to stop, unless you have a question. Okay, so a diameter would be the distance all the way across through the center point, through the center of the circle. And a radius, if I put the center here, again, it doesn't have to be perfect, but a radius would just be half that distance. Okay, now remember, a radius can be anywhere. It's like the spokes of a bicycle tire wheel, okay? This would be radius, halfway across the circle. The diameter would be the distance. I'm going to make this red to go with this red line. And then circumference, C, will be the distance all the way around. Okay. Now, how do we actually find the measurements of these parts? Well, we need to understand the relationship and the formulas in order to identify the correct measurements. So let's look at the diameter. Remember, diameter is twice the radius. Okay, think about that for a second. If I have a diameter, I have a line that goes all the way across through the center. Well, remember, half of this is called the radius. So how many radius are there in one diameter? How many? No, how many? The center point cuts everything in half, okay? So there's 2 radius, 2 times r in 1 diameter. You guys see that? Do you see that? Okay. And then the radius is half of the diameter. So again, think about it like this. My circle's not very good today. If I have a radius here, if I extended it all the way across, then that would be a diameter, right? So this radius that I'm interested in is half of this distance across the circle. So all I have to do is, if I know diameter, I can divide it by 2 to get half the distance across the circle. Okay, so these 2 relationships are important, and we'll get practice here in a second. And then last, we did diameter, we did radius, and now we're going to do circumference. And tomorrow we're going to pull out our star charts. We're going to start using them, but for today I'm going to go ahead and give you the formula. There are 2 formulas that you can use to calculate circumference. Jabari, I need you to sit up, please. Takaya, sit up, please. Circumference is equal to, you see this little symbol right here? That's called pi. Is anybody familiar with pi? A little bit, okay. So we could use pi times diameter, or we could use circumference is equal to 2 times the value of pi times the radius. Now, I'm going to help you out here simply because over the years, I've learned that it's easier to think of circumference in terms of this formula, and you'll recognize why as we go through this unit, okay? It's always better to start with diameter. Now remember, diameter is always larger than the radius, right? The distance across the circle is diameter, and that is definitely bigger than what? Halfway across the circle, which is radius. So my diameter is always greater than my radius. Okay, does anybody know what pi is? Do you know what it is? You've seen it before? Yes. Okay, all right. Well, this symbol, and you'll see me write it like this, okay? This symbol is pronounced pi, P-I, it's a Greek symbol, and we're going to explore what that is next. Okay, so let's look at the next page in your notes, which is page 2. And we're going to explore circumference of a circle. Now remember, what is circumference, you guys? It's the what? The distance what? Around the circle, okay? In order to analyze circumference and calculate circumference of a circle, we have to know what pi is first. So that's what we're going to find out. What is pi? All right. So we have this table. Micah and his friends work at a tire factory. The factory manufactures several different size tires for different vehicles. We need to fill out the table below to show how the diameter and the circumference, notice it's diameter and circumference, of the tires are related. Please make sure in your notes, the second to the last column right here where it says find the ratio, please make sure it looks like this. I think I updated it on everybody's packets, but just make sure. It should say circumference, fraction bar, diameter equals C fraction bar over D. Okay, so we have a vehicle and they list which vehicle it is, and then they show the diameter of the tire for that particular vehicle. So we're looking at a kid's bike or a little kid's bike, a regular size bike, a car, and a dump truck. So those are all different size tires, right? Okay, so the diameter, what's diameter, you guys? No, diameter is the distance across. Remember, diameter is the bigger number. So all the way across is bigger, correct? Okay, the diameter is, if you see a circle and you see the center and you have a line that goes all the way across, that's an example of diameter. So diameter is the distance all the way across the circle. That diameter for this bike is 14 inches. The diameter for this bike is 18 inches. And then what? And 36, which makes sense because they're getting bigger, right? The tires are getting bigger. And then we talk about the circumference of the circle. Now remember, circumference is what? All the way around, the measurement all the way around. So they're giving it to us. They've done the measurement. And they say for the toddler bike, the distance around that tire is 43.96 inches. For the regular bike, this measurement all the way around, and then the car, and then the dump truck, okay? Now what they're asking us to do in this table is to find this ratio right here. Now notice what we're doing. We're taking the circumference of the circle, or the tire, which is a circle, okay? And we're dividing it by what? By its diameter, okay? So for the toddler bike, for instance, we take C of 43.96 and we divide it by what? By the diameter, which is 14, okay? So how would we set up the next one? It would be what? 56 what? 0.52 over 18, okay? So go ahead and set the others up. It would be what? 75.36 divided by what? 24. And then the last one would be what? 113.04 divided by what? 36. Okay. Now, I don't know about you, but we're not going to sit here and do this all day. Okay. So I'm going to give you the answers. If you divide this out, you're going to get this number, 3 and 1400ths. And you're going to hear us say 3.14. That's what we always say. Okay. So then I go to the bike and I calculate this ratio, and that's going to equal 3.14. What do you think the next one's going to equal? 3.14. What do you think the next one's going to equal? 3.14. Okay. Okay, let's answer some questions here. Look at the diameters of these tires. Are they all the same? No, they're different, right? Okay, so they're all different. They're not the same. So they're different. We'll say different, okay? And then look at the circumferences. Are the circumferences all the same? They're different too, right? They're not all constant. They're not all the same. But what do you notice about the last column? So you mean to tell me that I can take the top of my collar, or I can take the bottom, right? And I can take the distance around those tires, and I can divide it by that tire's diameter. It doesn't matter what size the circle was. Does it matter? No. I still ended up with the same, doesn't it look crazy? And then label out number 5. That number right there is 5. Okay? Basically, that's how clear if you take the circumference of the earth. Let's say we can figure out, and they can measure it. Okay, let's say we take the circumference of the earth. This is around the earth at the equator. Okay? You take the circumference of the earth, which is a humongous number, and we divide it by the diameter, so we cut it straight across in the middle in the core. Okay? And I take the circumference of the earth, and I divide it by the diameter of the earth. What number am I going to get? 3.14. What if I took the circle at the end of that marker? You see how there's a circle? And I could measure around it. What if I took the circumference of this marker and I divided it by the diameter of the marker? What answer am I going to get? Guys, hear me out, because I guarantee you this will be one question on the test. I guarantee it. Okay? Pi is always equal to, if I have a circle, and pi is always equal to the relationship between the circumference as it relates to its diameter. That's just a fancy way of saying circumference divided by diameter. Okay? That's how it's diameter. Circumference divided by diameter. Always. And you have to remember that. You will see that question on this test. I promise you. It happens every year. You need to know that. Pi the diameter, and I always get what number? This is a constant number. And basically, this is just a fancy variable, and pi will always equal 3.14 unless you're told otherwise. Okay, we'll talk about that when it's for today. Okay, so you guys have to remember that. What is pi equal? Is the ratio of C divided by D. And it always equals what? 3.14. Okay, now, I'm going to blow your mind here. It actually doesn't equal 3.14. It equals 3.1415933. It goes on. It never stops. It never stops. So this goes on forever and ever. Okay? There's no repeating numbers. There's no patterns. There's no nothing. This is pi is what is called, you know how you study rational numbers? Well, pi is what's called an irrational number. And you'll learn about that next year later. Okay? So you need to make sure you understand what pi is. Pi is that ratio, and it always equals 3.14. Okay? Does that make sense to everybody? Okay. All right. So what we just found was the value of pi. So up here in our table, this column represents pi, which equals C circumference divided by D diameter. Okay? Okay. And we know that pi equals what value? It always equals what? 3 what? 3.14. Okay. How did we calculate the value of pi? We took what? Circumference divided by diameter. Very good. Okay, so now let's look to see how we're going to use this critical piece of information. All right, so circumference of a circle is the distance around the circle. It can be found using two formulas. Now, what we said before was we said this. We could use circumference is equal to 2 times the value of pi times the length of the radius, or we could use circumference is equal to pi, whatever the value of pi is, 3.14 times the circle's diameter. And pi can be approximated to 3.14 because we know that number never stops. So we just traditionally use 3.14. I'm telling you right now that I mentioned just a moment ago, this is the best formula to use, and you'll learn why as we go through these problems, okay? All right. Now, somebody commented about why the packet was pretty thick. This is why. Every problem, I'm giving you a graphic organizer to help us learn how to set these types of problems up. Okay, I want you to do problems the same way over and over again, so that you get used to creating the same mental habits, so that you'll approach these problems the same way time after time. Okay. We get out of here at what time? 57. Okay, let's start one of these real quick and we'll finish tomorrow. Now, I know this sounds very redundant, but just bear with me, okay? Find the circumference for this circle below. Okay, so I'm going to look at the picture. If one is not provided for you, you need to draw one. Look at what's given to you. Do you see this piece right here, this dashed line? It goes from there to the center. What does that represent? Does that represent diameter or radius? Because diameter is all the way across. So this is radius. So if it's halfway across the circle, it's radius. Okay. So what kind of a shape do I have? I have a circle. Okay. And what are we trying to find? We're trying to find circumference, and I'm just going to write CRUCUM. Okay, I'm not going to write the whole thing out. Okay, and the formula, what formula did I tell us to use? The best one to use? Pi d. So we're going to say circumference is equal to the value of pi times the diameter. Okay, now we're going to do what's called identifying the variables. So look at the formula. What variables do we need to know in order to use this to find circumference? Well, we have to know what pi is, and we know that. It equals what? 3.14. And we need to know what diameter is. So what's diameter? Well, if radius is 6, then what is diameter? It would be another 6 all the way across, right? So diameter is 12. Now, I will always ask you to find D and R for every circle problem, and you'll see why when we get to area. Okay? So when we identify the variables, always find for circles, find diameter, and find the value for radius. Pi is equal to 3.14 always. Okay, now we substitute into our formula and we simply say circumference is equal to pi equals what? 3.14 times the diameter of what? Come up here, we said what? 12. Do not multiply it times 6. The reason why I make you write it out is so that you pull it out correctly. So 3.14 times 12, I think it's 58.18, I think. And we'll talk about the rest of it tomorrow. Have a good day.